If our voltage stabilizer doesn't have 14.5 volt, we see the voltage stabilizer VIN pin on the circuit diagram. It is 14.5 volt or 18.5 volt. We have also seen from the circuit diagram, how did the circuit come about? It passes through a diode, also in a resistor with 10 ohm. You check if the diode D is damaged firstly. If the diode is not damaged, then we will check other. As you see on the picture, we have the MOSFET and the resistor. Then it has a MOSFET. P-channel MOSFET with S-pole in the D-pole out. This electricity comes from the adapter power interface. Then this 18.5 volt and 14.5 volt is from the power port. After our adapter is connected, it is delivered to this tube. We just said that if there is no electricity, first is the first detection element of the diode. R-pole is the second detection component. D-pole is the third detection component. Check the circuit down and it can be completely repaired. This circuit is relatively easy to repair. If the tube is broken, it can be short-circuited. It was mentioned in the circuit analysis just now. Connect D-pole and S-pole with tin or jumper wire. This is how to repair the VIN pin without electricity. Then we will talk about the second key circuit after 3.42 volt, which is our protective isolation circuit. This protective isolation circuit is also relatively easy to damage. What is the main function? It mainly acts as a charging IC to control the power supply and battery operation. So the above is the working principle of this first point. Let's talk about the second point below. The voltage point it generates is called the public point or the common terminal. This voltage of MacBook is mainly controlled to generate 8.6 volt. It is formed by changing the voltage of 14.5 volt or 18.5 volt adapter to 8.6 volt through the circuit. This circuit is also easily damaged. Compared with the 3.42 volt, the circuit has a higher probability of damage. The voltage function of the public points to supply power to our back-end, PWM and high-side MOSFET depot. Including some small ICs also need to be measured their voltage at 3.5 volt IC and CPU power supply IC. These voltages are all generated by common points. It is not the same as an ordinary laptop. The power supply voltage of our ordinary Windows computer is 90.5 volt or 90 volt. And the power supply voltage of our MacBook is 8.6 volt to 9 volt. What are its main components? Power ring from our power plug, power supply or battery port. Then there are our charging IC, isolation tube. It is an orthogonal MOSFET, a PMOS. Charge and discharge high side and low side MOSFET. And now charging inductor. In maintenance, if we measure the common point, just measure whether there is 8.6 volts on the large inductor to know if the public point working. Measure public point voltage during maintenance. If there is a voltage about 8.6 volts on the charging inductor next to the battery interface, if there is a voltage of about 8.6 volts, it means that the isolation circuit is normal. On the other hand, if there is no 8.6 volts, it means that the isolation circuit is damaged. It will also cause our laptop to no boot. So how to analyze this circuit specifically? Let's analyze how this circuit works through the circuit diagram. How does the charging IC control this tube to complete the process of battery and power supply work? Below we use a circuit diagram to point out what these components look like. Let's look at some of the key components involved in the charging and the circuit diagram. Take a look. First of all, U700 is the charging IC. Relying on the public point inductor of the charging IC, L7030 is our charging inductor. In other words, the voltage of public point test point is here. If there is no within the inductor L7030 here. Measure up to this point at the time. If there is 8.6 volt, the circuit is good. No 8.6 volt means this circuit has been damaged. Then there are key components. Q7030 is upper and lower tube for charging. This is the third component we need to know about high side and low side MOSFET for charging. Look at the picture. It is also an N-channel MOSFET Q7030 upper and lower tube for charging. So there is another key component here, our isolation tube. Let's take a look. Q7080 and Q7085 are isolation tubes. Means that the fourth type of component. This is the isolation tube. This model and my picture are relatively easy to damage. In addition, add the R7020 here, which is precision resistor. This component is also relatively easy to damage. It plays a role in detecting current. So it's in the actual maintenance. Let's take a look at one more thing. Our frame adapter comes from the adapter interface. We pass 80.5 volts and 40.5 volts through this tube, sending to our precision resistor and then to the depot of the upper tube. It is also a kind of PWM power supply. In other words, it is sent to our upper tube through this electricity, which is also second pin of the Q7030. It should be 18.5 volt or 40.5 volt in this position. Let's talk about it based on the 40.5 volt later, because most of the new model now are 40.5 volt. If there is no electricity, this time you have to see the isolation tube from the adapter interface. Is there any component damage on the line to the isolation tube? This is how its electricity goes. Let's take a look. According to the direction of my red line, through precision resistor. Came here first. It didn't work for this tube. Just provide it with a working condition first. So here the U7000 charging IC is very critical. It is mainly to control the voltage of the inductor at the common point. The Q7030 is controlled by the U7000 charging IC to turn on and off to charge and discharge the inductor. Send this electricity to each of those. Take a look, there is another key component here. Q7055, this component is called the discharge and charge tube. The tube is also very important. But many of the isolation circuits are not analyzed. Here I will emphasize this tube to you. It will cause a situation. It is responsible for charging the battery if there is electricity at the public point. In addition, it also has a discharge function. When you unplug the adapter, the battery's electricity is also sent to the public point through the battery interface. The battery's electricity comes through this way. That is the D pole comes in and the S pole comes out. The same reason also sent to our public point up. The light of the tube will cause a single-use battery to not turn on or charge. This situation is a little bit more. This is a case that the battery does not turn on when the single-use battery, but the power can be turned on. The two circuit can be called discharging circuit or charging circuit. It has a dual functions. When the power is unplugged, the battery discharges the load through this tube. When the battery is low, it in turn recharges the battery from the public point. And the tube has this function and is relatively easy to break. So what do we mainly analyze when analyzing the charging circuit? How does charging IC work and how to control this tube to work? If in this common point voltage was maintenance, I measured that the voltage on the inductor is not 8.6 volt. That means this circuit has been damaged. So let's take a look at how the charging IC works. How the charge to work. Let's go back and erase the graffiti just now. Okay, let's zoom in and take a look. Do these two key charging IC work? The key is to see if there is a square wave output on these two tubes. These two are square waves, and we can detect that they are square wave with an oscilloscope. It is sent to the G of the upper tube. This is the G of the lower tube. The two tubes are conducted in turn, not synchronously. Sent to the G of the down tube. In other words, there is no electricity at your public point. First of all, it is crucial to measure whether the G of the MOSFET has a waveform. If the G has the kind of waveform, it doesn't matter with charging IC. The problem is in our isolation tube or the charging tube. The principle of switching point is to use an oscilloscope. In the actual maintenance, it may be due to the limitation of the condition. Many people don't have an oscilloscope, so we can only use a replacement method. Test the quality of the MOSFET now and then charge the IC. This kind of standardized operation method is taught here for everyone. In fact, when conditions do not permit, we can test IC. How does this IC work? If the G has no waveform, first the IC needs power supply. Let's take a look at the power supply of the DCIN pin. Here it is a key pin. It comes from the adapter. It should be 14.5 volts. If there is no 14.5 volt, we have to follow this line road to find. Look, they came this way. First, see if the resistor R7005 is damaged. Cross over through this resistor. Well, if this resistor is not damaged, then it means I will see if the diode D7005 is damaged. The The maintenance rule is follow up. Follow its main line to find. Find this component through the BMAT. Was there a problem with the dial D005 immediately after it was detected? If there is no problem, take a look. Here is voltage interface from our adapter. It comes in through this dial, which is a composite dial. That is to say, the voltage of the adapter is first sent through the dial and the R705. The DCIN pin of the U7000 sent to our charging IC. After DCIN pin receives the power, let's take a look at another key test pin, ACIN. This is second pin. It needs to receive the signal. Why is this signal used? Core adapter plug-in signal here. It is generally around 3.8 volt. Send to this ACIN pin. So how is this voltage generated? Take a look at the ACIN. Let's zoom in and see the drawing. It is a line route. Look at the above is coming from the adapter, passing through this dial. After R7010, a 66.5 kilo ohm resistor, 1000 ohm resistor comes through this. A pull-up resistor and pull-down resistor. The pull-down resistor is a bus circuit and is connected to the ground. The resistance of the ground wire was divided by the two resistors. Two resistor divider generates the electricity of the ACIN pin. In other words, the charging IC wants to work. The first condition is that DCIN must work first. Then through these two resistors, R7010 and R7013, it needs to divide the voltage to generate 3.8 volt to DCIN pin, which is power supply pin. Then it outputs another voltage. This is the third step. This is a 5 volt voltage. This IC will generate a 5 volt voltage out. There is a mark on the picture here. Let's take a look at the voltage of 5.1 volt out of the actual measurement of 5 volt. If there is no 5 volt, we will replace the charging IC directly. If there is a 5 volt, it passes through a 4.7 ohm resistor. The VDDP sends to us supply power to the 20th pin of the IC. Pay attention to the R701 resistor. It is also relatively easy to damage. In the maintenance, we mean to focus on the measurement, and then turn the power supply detection signal output 5 volt voltage. 5.1 volt is marked on the picture. Actually, this is 5 volt. It is normal to be close to it. What does it do with electrical output? Send to the VDD pin of the IC through this resistor. After IC has it, there is another key signal pin to remember. This IC will generate ACOK. Let's take a look at this pin. ACOK signal to tell EC. This is third step. This is fourth step. Let's draw it again. Send to this IC, this is fourth step. Why do EC? It will be analyzed in detail in the later circuit. It's the electricity and the signal comes out. ACOK causes power good signal. It comes out with 3.42 volt. After these voltages are normal, it only outputs these two square waves. The upper tube is turned on first, then the lower tube is turned on. But before there is no work. Of course, we had talked about it just now. This electricity must pass through the isolation tube with an oscilloscope, 18.5 volt and 40.5 volt. It has to pass through these two isolation tubes. Look, depot in. It has passed the isolation tube to the depot of the upper tube. There is no voltage at the public point. First of all, you have to see if the point has 40.5 volt. test the depot of the upper tube or test the resistor. This resistor can also be measured. It should be 40.5 volt. If there is no 40.5 volt, we'll find it from the circuit wire array. These two tubes Q70AO or Q70A5. The probability of damage to these two tubes is quite high. The resistor including the 0.2 is also relatively easy to damage. This resistor that can be shorted. The two tubes can also be short-circuited with one of them. Try not to short it. Try not to short-circuit during maintenance. Then after two tubes are turned on, the inductor is our public point. We can also see through this principle. If there is no voltage at this public point, that means there is a problem with the circuit line. Let's take a look at the overall review. We plug in the adapter 14.5 volt through the isolation tube and charging tube. It is a depot of the upper tube. At this time, it hasn't worked yet. It is necessary to wait for the charging IC to meet the conditions before it can work. What kind of condition does the charging IC need to meet? First of all, 40.5 volt electricity passes through D7005 and R7005. Send to the DCIN pin of the IC to supply power to everyone. That is, the second pin is the U7000 needs to be sent to the power supply. After the U7000 receives a power supply, our 40.5 volt is stepped down through the two resistors R7010 and R7011. Generate a voltage of about 3.8 volt and send it to the ACIN pin. After these two conditions for enter are met, 90 pin will output a 5 volt through R701 with 4.7 ohm insurance resistor. Send to the 20 pin of the IC to supply power for the VDDP pin. Okay, then we output the 40 pin and send our CHGR ACOK. Here is adapter for good signal. It is sent to the circuit EC back. In other words, when there is no electricity at our public point, we have to check the components of these key pins. As long as any one is damaged, it may cause the voltage of the public point to be abnormal. The most easily damaged may be the Q7030 here. Generally, inductor is not easy to damage. R7030 at the public point, the inductor itself is not easy to damage. Generally, ICs and these tubes are more easily damaged. These are key working conditions. How is the voltage of the public point generated? That is how the adapter works. When applying the adapter, how does this electricity flow? This is a working principle of the protective isolation circuit. Then let's talk about the public point circuit. How can it be checked? The public points through charging large inductor. There is a large charging inductor next to the battery interface. Its different models have the same principle. A1468 is representative. The large charging inductor is generally next to the battery port, the largest one, measured on the large inductor of L7030. If it does not have the 8.6 volt, it is normally about 8.6 volt. If there is no 8.6 volt in the maintenance, it means that there is a problem with the protective isolation circuit. Cause no boot. So how to repair it? There is also our key point. We can just learn the principle and not practical maintenance. The purpose of our principle is to repair. If there is no 8.6 volt, it means there is no voltage at the public point. How to repair if there is no voltage in the public point? This is very important. Early maintenance means that check the resistor value of the public point to the ground. So how should we check the resistor to the ground here? There are three situations the same. The first is that the resistor value is OL, open circuit state. The second is the value of the resistor shorted is 0 and close to 0. This is called short circuit state. The third type is a resistor value between about 300 to 800. It is connect circuit normally. Causing it has no voltage. You must first check resistor value to the ground. Check whether it is caused by the short circuit or the open circuit. In the basic course, we also mentioned the method of checking the resistor to the ground. By the same reason, I hope everyone will strengthen and review the ground resistor part of our basic course. To avoid mistakes in operation, the resistor to the ground detection is very important in the later maintenance of the circuit, including our protected isolation circuit. So here we will emphasize every lesson. So which components are generally focused on when opening circuit? This open circuit is generally easier to repair. First, we check the power port and adapter interface. Is it broken or dirty? The power port usually has an insurance, remember it. Is it burned? Secondly, the isolation tube needs to be tested. It is a P channel. Thirdly, precision resistor. Fourth, the charging board. Relatively speaking, the maintenance of open circuit is relatively simple. We hardly need to look at the drawing. We can directly measure whether there is any problem with following. Relatively speaking, there are more short circuits. Generally speaking, the chance of opening is relatively less in actual maintenance. The point is that the following two situations encounter a little more. Okay, how to fix a short circuit? Generally, we use the burning method. How to burn it? This is critical. First of all, the first step of burning method is to draw out the large inductor flying rule wire of the public point. The second step is power with the power supply. Or use tweezers to clamp the jumper. Clip flying out of the wire clip. The voltage of the power supply can be adjusted. Slowly adjust the voltage from the 0 volt upwards. Slowly increase no more than 8.6 volt or 9 volt. While adjusting the touching, we find that the certain IC is hot and we will replace it. Found that the certain capacitor is heating up, we can pull it off and not install it. This method is faster. Whether it is a Windows computer or a MacBook, this is one of our most commonly used methods, called burning method. Remember that the voltage cannot be super high, from 0 volt to 8.6 volt increasing slowly. Don't adjust 8.6 volt at once so that the circuit board is easy to burn through. There are risks, so we can only increase slowly. This burning method is also more commonly used, including the circuit be high as long as the burning method is mentioned. We'll power up this circuit from low to high, slowly adjust to make jumper. This is what we call the burning method. It is how to fix a short circuit of the public point. Okay, what about the normally connected circuit? Then the method of connecting circuit will be relatively more troublesome. Generally, there is no voltage in normal if connect circuit normally, so we have to look at the drawing. Either the charging IC is broken. In maintenance, most of the charging ICs are generally replaced directly. If the charging IC is changed, it is not good. At this time, we have to open the drawing and open the PDF of the charging IC. Like U7000, some of its components with key pins. We also mentioned this in picture just now. Which pins of the U7000 are the key components to be checked? Which pins are there? Mainly DCIN. It is 40.5 volt, has it come in here? The second one is ACIN, the 3.8 volt come in here. If both of these power sources come in, it does not mean the IC is good. 5 volt out of VDD. There is also a 4.7 ohm resistor to the VDD pin. It is 5 volt. We mentioned this in the schematic. This key point needs to be checked. There is another key signal, ACOK. It is easily given to her by 3.42 volt. Then how to measure the voltage of the public point and how to fix it if there is a problem. Relatively speaking, the public point circuit of the MacBook are easier to repair. Because first you need to have a drawing. We'll look at the drawing, and then you will check the resistor value. Find these components through the bitmap. This schematic diagram helps us analyze the principle, and the bitmap helps us to find the components. These two pictures are essential for repairing the Mac. This is a working principle, maintenance step and circuit analysis of the protected isolation circuit discussed in this class. Everyone should review and read more after class. Goodbye.